Hello, just want to welcome you. Thanks for coming to a webinar on the global glyphosate study, which was led by the Ramazzini Institute in Italy and was published on the 10th of June. I'm Josie Cohen. I'm the interim director at Pan of interest in this webinar, with more than 1,800 people signing up from all over the world. Attendees are from a wide range of sectors. So in addition to concerned members of the public, we have people from government, academia, civil society, and all different parts of the private sector. So it's really fantastic to see the level of interest. I'm just going to give a very quick introduction before handing over to our speaker, Professor Michael Antoniou, who is the Professor of Molecular Genetics and Toxicology and Head of the Gene Expression and Therapy Group at King's College London. We're very lucky to have Professor Antoniou willing to speak to us today. He's the main event, but please do submit questions in the Q&A box in case there's any time at the end. Just quickly, who is Pesticide Action Network UK? We were founded in the 1980s. We're part of a global network called Pan International. We focus on tackling the problems caused by pesticides and promoting safe and sustainable alternatives in agriculture, urban areas, homes and gardens. We apply pressure and also advise governments, regulators, policymakers, industry and retailers on how they can reduce the impacts of harmful pesticides to both human health and the environment. We weren't involved in the global glyphosate study, but we are delighted to be able to host this webinar with its only UK-based author. So a very quick introduction to glyphosate, and Professor Antoniou will obviously expand on this, but it's the world's most widely used herbicide and the world's most widely used pesticide. It's used primarily in farming as a weed killer, including as a pre-harvest desiccant. And it's also used in the amenity sector, particularly in public spaces in towns and cities, and by amateur gardeners. There's a growing body of evidence showing that glyphosate is causing environmental problems, including contaminating water, impacting aquatic species, and harming pollinators. But today, we're going to be focusing on the impacts of glyphosate on human health. So just to conclude, while today's focus is on glyphosate, many of the issues Professor Antoniou will cover apply to a wide range of pesticides. Our work is not about replacing glyphosate with another synthetic herbicide, many of which are equally or even more harmful. Studies like we're going to look into today highlight the problems with our over-reliance on pesticides in general. We need to tackle the forces that are driving current levels of pesticide use and support farmers and other land managers to adopt safe and sustainable alternatives which enable humans and the natural environment to thrive. With that in mind, I'll hand you over to Professor Antoniou, and just let me give you his bio very quickly. He's, as I said, he's a professor of molecular genetics and toxicology. He's a molecular biologist and has been a member of the Department of Medical and Molecular Genetics at King's College. In 2013, he expanded his research into molecular toxicology. He specialized in molecular composition profiling to measure outcomes from exposure to chemical pollutants, including pesticides. He also examines their effects on the gut microbiome. His research group has become a world leader in glyphosate herbicide toxicology. So thank you so much for finding the time to speak to us today, and I'll hand over to you.
Thank you very much, Josie. I'll just share my screen here so that get up my presentation. I hope this is, everybody can see this clearly. First of all,
perfect, Michael. Yeah.
Good. So first of all, I'd like to express my thanks to Pan UK for arranging this webinar, giving us the opportunity to present the findings of the carcinogenicity arm of the global glyphosate study recently published. So the title of the presentation I've given is, Are Glyphosate Herbicides Carcinogenic? What the latest science tells us. First of all, I mean, Josie gave a good brief background to glyphosate, but here's a few other basic facts we need to bear in mind as we go forward. What is glyphosate exactly? I've got the molecular structure here on the right, but it's basically a derivative of the amino acid glycine, and its chemical name is N-phosphonomethylglycine, and it was first synthesized in 1950 by a Swiss chemist. Then in 1970, Monsanto Company, as it was known then, discovered that actually glyphosate can act as a potent herbicide, weed killer. And in 1974, it launched glyphosate-based herbicides under the trade name Roundup. And these herbicides exist today. So glyphosate herbicides since then have become the most used pesticide in the world ever. They are broad spectrum herbicides. Glyphosate-based herbicides are broad spectrum herbicides. They're non-selective and will kill virtually any plant. They're globally the most heavily applied, and their use continues to rise. And the rise in the last few decades has been driven by the introduction of genetically modified crops that are tolerant to the application of glyphosate herbicides. And you can see the escalation in application here on the graph on the right. But it's also used not just on glyphosate-tolerant GM crops, but there's massive use as a pre-harvest desiccant, especially on cereal crops and other applications as well. And because of the large-scale use of glyphosate-based herbicides, there's widespread environmental pollution and presence in foodstuffs, and large-scale population exposure, both occupational and non-occupational. Unfortunately, I'm sure more than 50%, based on surveys in Europe, most of the people, more than half the people on this call today, if we analyze your urine, we'll probably find glyphosate present. In the United States, it's virtually 100% of people will have glyphosate, detectable levels of glyphosate in the urine, showing that there's this daily exposure to this chemical. The way that glyphosate works as a herbicide is through inhibiting a biochemical pathway known as the shikimate pathway. I don't have time to go into it in great detail, but basically the shikimate pathway, which is present in plants, is responsible for the synthesis of essential amino acids, these tryptophan, phenylalanine, and tyrosine, these so-called aromatic amino acids. And by inhibiting a key enzyme in this biochemical pathway, known as EPS-PS synthase, the plant can't synthesize these amino acids and therefore dies. And because the shikimate pathway is not present in animals or humans, it was claimed very early on that to be completely safe. However, what this claim of safety based purely on the absence of the shikimate pathway in humans and animals ignores the fact that the shikimate pathway is present in bacteria and fungi, including microorganisms in our gut microbiome, so it could negatively impact that area of our physiology. But also it ignores other mechanisms of toxicity that are particularly relevant to our discussion here today, which is that it may cause oxidative stress and DNA damage or genotoxicity, as it's generally known. So with that background, let's go on and see how things stand. First of all, there's one other concept we need to be aware of from a regulatory perspective, because this is what is being challenged by the global glyphosate study data that we'll be going through. The regulators for all chemicals that are deemed to be potentially or actually toxic, regulators set an acceptable daily intake for that given chemical. What the acceptable daily intake is what regulators stipulate as saying that if we ingest this amount of this chemical on a daily basis, day in, day out, for all of our life, we will suffer no adverse effects from it. So the regulatory permitted acceptable daily intake of a potentially toxic chemical is based on establishing what is known as the no observed adverse effect level, or NOAEL dose in animal toxicity studies. So it's an important point to raise at the beginning. Regulators require animal toxicity studies to be undertaken with a chemical at different doses to establish this NOAEL dose. And that's what has been done for glyphosate. And then in 2015, the European Food Safety Authority, in their conclusion paper, they based on animal studies, they established they felt the animal studies established a no observed adverse effect level or no AL level of 50 milligrams per kilogram body weight per day of glyphosate. And this was based on maternal and developmental toxicity study in rabbits. And what regulators then do, they don't say, oh, humans can consume 50 milligrams per kilogram body weight per day, because obviously rabbits are different from humans and there's diversity among people as well. So they also apply what is an uncertainty factor, and this is usually 100-fold. So applying an uncertainty factor of 100-fold, EFSA came with an acceptable daily intake of glyphosate of 0.5, half a milligram per kilogram body weight per day. And this is, and I just mentioned in passing that when they reviewed studies in rats, they felt the NOAL value was 100 milligrams per kilogram body weight per day. But because there was this adverse effect at the lower level in rabbits, they went with the 50 milligrams, which was sensible, obviously. So just to summarize that then, the EU and the UK NOAL value for glyphosate is 50 milligrams per kilogram body weight per day, and the acceptable daily intake, or ADI, as a result, applying this 100-fold uncertainty factor is 0.5 milligrams per kilogram body weight per day. And so for an average 70 kilogram human, that means they can consume 35 milligrams per day of glyphosate day in, day out, and not worry about any adverse reactions. This, I have to say, is a rather high, exceptionally high ADI for chemicals. I should also, just in passing, add that the ADI in many other nations around the world is twice the UK EU value and is at 1 milligram per kilogram body weight per day. So if one finds adverse reactions at half a milligram per kilogram body weight per day, then it's going to be potentially worse if it's 1 milligram. So this is one concept to bear in mind as we go forward, this acceptable daily intake based on the NOAL, based on animal toxicity studies. The other point to bear in mind as we go forward is that pesticides are never used as the active principle alone. So in other words, glyphosate is never sprayed as a pure chemical on crops or weed or plants, I should say, weed species to kill them, either agriculturally or domestically. They, when you buy, or when a farmer or buys, or if a gardener buys a glyphosate-based herbicide, it contains glyphosate plus a range of other chemicals, collectively known as co-formulants, that enhance the or allow the glyphosate to exert its herbicidal activity. For the most key being that these co-formulants punch holes in plant cell walls, allowing glyphosate to enter the plant to exert its toxic effect and kill it. Oops. And the reason I mentioned the importance of these co-formulants in the context of our discussion today is that they are toxic in their own right. So what work conducted many years ago now has shown that glyphosate-based herbicides as a commercial formulation can be up to 1,000 times more toxic than glyphosate alone. Many times these co-formulants are not disclosed, and in the United States on the label, they're even not only not disclosed, but they're labeled as inert, as if they do not have a toxic effect. But that is simply, the science says that it is simply not true. I'm mentioning this now because, in other words, when we consider the toxicity of glyphosate, commercial glyphosate application, we have to consider not just glyphosate, but it as its commercial formulation, as bought and used by farmers and even by gardeners. In terms of some of the co-formulants, and there's many of these used in different formulations of glyphosate-based herbicides around the world. There's some of them are in this diagram on the left as you look at it. And I'll be showing you results of 2 commercial formulations that have these 2 co-formulants, POEA, or polyoxyethylene toluamine, and Dogigen 4042, which has propoxylated quaternary ammonium surfactant. So bear that in mind as we go forward as well. Now, this is about cancer. It's about the global glyphosate study carcinogenicity arm of the investigation. So we should consider what are the characteristics of carcinogens or cancer-causing chemicals. The International Agency for Research on Cancer, which comes under the World Health Organization umbrella, some years ago defined 10 key characteristics of human carcinogens, and they are in this diagram on the right, as you can see. The two that I wish to, out of this 10 that I wish to highlight here is, first of all, the fifth characteristic, which is carcinogens induce oxidative stress. Oxidative stress results from the production of what is known as reactive oxygen species from our oxygen respiration. And normally, ROS actually perform vital metabolic functions. But if there's too much ROS, more than the body can detoxify, then it causes oxidative stress. And this is, again, with health implications, because ROS are highly reactive. They are reactive oxygen species, and they will attack and damage proteins, cells, and even DNA. They can result in DNA damage. And this links in with the second characteristic of carcinogens, which is genotoxic or damage to DNA. So oxidative stress is one major mechanism through which DNA can be damaged, gene structure and function can be damaged, and that is a key characteristic, a major risk factor for developing cancer. So this is the background information I wanted to cover. The issue of whether glyphosate herbicides are linked with cancer, are potential carcinogens, kind of came to the fore in 2015, when again the WHO, International Agency for Research on Cancer, or IARC for short, published its evaluation of the carcinogenicity of five organophosphate chemicals that included glyphosate. And with glyphosate, as you can see in this table, the IARC committee felt that there was some but limited human epidemiological evidence of a link between glyphosate herbicide exposure and non-Hodgkin, a cancer known as non-Hodgkin lymphoma. But they felt there was ample evidence, sufficient evidence from animal studies that glyphosate herbicides cause cancer. And mechanistically, they felt that these were arising from genotoxicity or DNA damage and oxidative stress, which, as I mentioned earlier, are linked. So based on this evidence, they classified glyphosate as a grade 2A probable human carcinogen. And you can read more about the scientific evidence that IARC used for its evaluation in these two publications that I've highlighted here on the bottom right. So this leads us to the global glyphosate study that was put together by the Ramazzini Institute in Italy. And it has many different arms, one of them being the carcinogenicity arm, which we will consider today. And I should just mention that overall, the design of the global glyphosate study is compliant with good laboratory practice and therefore compliant with regulatory requirements, regulatory agency requirements of any agency around the world. The study consists of using the Sprague-Dawley rats. Sprague-Dawley rats are used in the vast majority of chemical toxicity studies, not just by academics, but by industry as part of its application for regulatory approval of its chemical inventions. So more than 55+% of toxicity studies are undertaken with the strain of rats. So it was logical for the Ramazzini Institute to use this strain. And the study starts from a prenatal exposure. So exposure was in pregnant female rats, and then the pups that were born continued the exposure to 104 weeks of age, to 2 years of age. 3 doses of glyphosate were given to the rats that span the regulatory relevant doses, which are 0.5 milligram per milligram, 0.5 milligram per kilogram body weight per day, which, if you remember, is the acceptable daily intake, regulatory acceptable daily intake. Then 10 times that amount, 5 milligrams per kilogram, And then the no observed adverse effect level, the NOAL, 50 milligram per kilogram per day dose was also administered. And then in addition, so this is one of the features. The global glyphosate study has many unique features with respect to the carcinogenicity arm. One is it's the first study to actually evaluate long-term the acceptable daily intake of glyphosate. In other words, doses below long-term below the NOAL. But also what's unique about the global glyphosate study is that it has compared glyphosate alone in a long-term carcinogenicity study of two commercial formulations as bought and used by farmers. Roundup Bioflow, which is a representative European Union commercial formulation, and Ranger Pro, which is a commercial formulation used in the United States. And just to put this in context in terms of the co-formulants that are present in these, Roundup Bioflow has Dodigen 4022, the propoxylated quaternary ammonium surfactant, as a co-formulant, as the main co-formulant. And Ranger Pro has POEA or POE15, taloamine, as the surfactant. So this is the paper that will be, the results of which we'll be considering today, published on June the 10th, carcinogenic effects of long-term exposure from prenatal life to glyphosate and glyphosate-based herbicides in sprague dawley rats. And as I mentioned, this study was led by Daniele Mandrioli and his team at the Ramazzini Institute. Here are some key elements, basic foundation elements to the study. First of all, the feed and the drinking water and the bedding the animals lived on was analyzed for chemical pollutants, including especially glyphosate, and that was all negative. We need to make sure we have a zero baseline to compare against. As I mentioned earlier, the exposure to the glyphosate and the glyphosate-based herbicides, the GBHs, was from gestational day 6. The pregnancy period of rats is 21, and the animals began their exposure at 6 days of pregnancy. And then the pups that were born then continued their exposure post-weaning until to a maximum of 104 weeks of postnatal life. And the chemicals were administered through their drinking water. There were 51 males and 51 females in each control and test group. And the histopathological evaluation to detect any cancers that were present were performed by at least 2 pathologists, and all lesions were peer-reviewed. And the control reference, there were 2 control reference groups. Most important, the concurrent controls in the study, in other words, the 51 males and 51 female rats that did not receive any glyphosate or GBH. And then these data was also compared to historical controls. In other words, the history of cancer incidence in the colony of rats at the Ramazzini Institute going back many decades, and also the colony of sprague dawley rats that the National Toxicology Program in the United States has data on. So when you go to this paper, you'll see that all the data is presented in tables such as this. And when you first look at this, they look quite, I must admit, they look quite daunting, but actually they're very simply and logically laid out. What you have on the left-hand side here is the result from the control group, and then the 3 doses of glyphosate, because this table summarizes the incidences of different types of leukemia from the rats exposed to glyphosate alone compared to the control group. And these are the different types of leukemia that were looked for: lymphoblastic, monocytic, and myeloid leukemias. These are total lymphoid leukemias, as you can see there. And so it's very easy. You see the control group, M is for male, M is for female, number of animals, 51, 51. And you just look for the numbers across here. And as you see, for male animals, 51 animals, for all these different types of leukemia, it's a 0. In other words, none of these animals suffered any of these types of leukemia. And similarly for the females. zeros, no leukemias. You can focus in the end at the end here, where it's all leukemias, 0. And then below that, you have the males and the females exposed to the ADI of glyphosate, 0.5 milligram, then the 5 milligram dose, and the 50 milligram NOAL dose of glyphosate. And again, you read across, and what you find is, for example, the ADI of glyphosate for the lymphoblastic leukemias, there were none at all. But one male animal suffered from monocytic leukemia, and in the female group, we also had one animal that suffered from a myeloid leukemia. And so you read down, and what you find basically is that although there are no leukemias in the control group, the leukemias were detected at all doses of the glyphosate group, including, most worryingly, at the lowest dose, which is the acceptable daily intake. This is the intake, remember, that regulators say that can be consumed on a daily basis without any adverse effects. So although the total numbers of leukemias is small, they are still highly statistically significant using standard statistical analytical tools. It was found to be highly statistically significant. And when we now look at the glyphosate formulations, this is now with the Roundup BioFlow, there were leukemias at the glyphosate NOAL dose, and there were leukemias at all doses of the Ranger Pro. And probably this difference reflects the fact that the co-formulant in Ranger Pro is more toxic than the co-formulant in the Roundup BioFlow. You can see, and also you'll notice that the leukemia incidences are actually higher than in the glyphosate alone at similar doses. The other thing that was noticed that was striking in the leukemia, in the animals that suffered from the different leukemias, was that 43% of the rats with leukemia in the glyphosate and the glyphosate herbicide treated groups died before the first year of life, as you can see on this chart on the left here, where the black symbols represent deaths, and the dotted line here is 52 weeks or 1 year in life, and you see large numbers of these animals died before then. And whereas when you look historically at the groups of the Sprague-Dawley rat colonies at the Ramazzini Institute and the American National Toxicology Program studies, basically none of them ever died from leukemia before the first year of life. So this is indicating that these are very malignant, very vigorously growing leukemias resulting in early death. This is now showing you the results from the glyphosate versus control group for benign and malignant tumors of the skin. Same principle applies as on the previous slide for the leukemias. And what we find is, again, that for the control group, there were no types of skin tumors detected in the control group, whereas all skin cancers, both benign and malignant tumors, were detected at all doses in the glyphosate exposure group again. These are the different types of skin cancers across the top. And you could see that for the squamous cell carcinoma, there were an incidence in both the male and the female animals, the sebaceous in the male here, and in malignant tumors, there were 2 in the male group and 1 in the female group. So again, we have this worrying finding that even in the lowest dose group, we had of the acceptable daily intake, we have highly significant numbers, increasing numbers of benign and malignant skin tumors. And for the formulations for skin tumors, again, we have skin cancers at all doses of the Roundup BioFlow and at all doses of the Ranger Pro as well. These will be the last set of tables I'm going to show you. These are for the glyphosate and commercial formulations, increased incidence of benign and malignant tumors in liver And the reason I want to show you this, I don't want you to go away thinking that in the control group, there were no cancers detected at all. Actually, there was one cancer found in one of the male animals, a hepatocellular carcinoma, a liver cancer. But the numbers of cancers in both the glyphosate treatment groups, and the two glyphosate herbicide groups were much higher. So glyphosate induced high levels of hepatocellular adenomas and carcinomas, as you can see from these numbers here, where there was none in the control, but a number in the glyphosate treatment. And similarly, with hepatocellular carcinomas, there were much higher numbers of cancer incidence of liver cancers there too. And that in cancer alone, in glyphosate alone, and in the two formulations. This is just summarizes the incidence of the study as a whole, because I have to warn you, there are 18 data tables in this paper. Obviously, I can't go through all of them with you here, but this summarizes the results. And what I'd really like you to focus on here are where the double arrows are indicated, because this is where tumors with statistically significant increased trend in incidence compared to concurrent controls. In other words, this is where the test groups were compared to the control group within the study rather than the historical controls. And so where you see a double arrow shows that there was highly statistically significant increase in tumor incidence. And you could see there's a whole range of different cancers whose incidence has gone up in male and female animals, especially in the males, that range from leukemia, skin, liver, thyroid, nervous system, bone, and mammary gland. Interestingly, the only mammary tumors that were detected in these animals were in the males and not in the females. And also that similarly in the Roundup Biflow and the Ranger Pro formulation exposure group, again, we find many different cancers arising, but also some cancers that are arising only at a statistically significant level in the formulations, as you could see here, the kidney, urinary bladder, and hemangiosarcomas in uterus and spleen and the pancreas. These were only significantly increased with the formulation exposures. And there were also some sex differences as well, as you could see. The bone tumors were found in both males and females, but the liver cancers are only found in males, and mammary cancers were only found in males as well. Just to put this into a human epidemiological perspective, this is all in rats. Is there any evidence in human epidemiological studies that glyphosate herbicides increase cancer? This meta-analysis from Leanne Shepard's lab found that in higher exposure group, this is an occupational use of Roundup herbicides, glyphosate herbicides in the United States. What Leanne Shepard's group found was that in the higher exposure group, there was a 41% increased risk of developing a cancer known as non-Hodgkin lymphoma. And in this really excellent review by Dennis Weisenberger, published just quite recently, and this is summarizing human epidemiological studies since IARC published their work in 2015. And what Weisenberger found here, that there were six case control studies looking at evidence of glyphosate herbicide linkage with non-Hodgkin lymphoma, and he found that 5 of the 6 studies were well powered, and that all these showed a positive association. So there's very clear epidemiological evidence now, I believe, that links glyphosate herbicide use with non-Hodgkin lymphoma, which is a very serious aggressive cancer. And in these 2 studies here, led by Vicky Chan in Jonathan Hoffman's group at the NIH in the United States, they have found clear evidence of oxidative stress, which is a DNA damaging agent, which I described earlier, that can take place in our bodies. They found that oxidative stress can take place in glyphosate use individuals, and that they have evidence for genotoxicity in terms of loss of the Y chromosome in male farmers as well, that could be stemming from the oxidative stress. So to begin to summarize, what are the conclusions that we can draw from the global glyphosate study? First of all, the global glyphosate study embodies many unique features. It starts with a prenatal commencement of exposure until the maximum age of 2 years postnatal life. So it better reflects real world exposure levels. When we get exposed to chemical pollutants, we don't get exposed to them starting in early adulthood. We get exposed to them from within the womb. And so this study tried to reflect that real world exposure scenario. It was unique in employing three regulatory 11 doses spanning the EU NOAEL and ADI. And it was unique in comparing glyphosate along with representative commercial formulations long-term in a carcinogenicity context. And the study design and execution were completely in accord with regulatory criteria. So the exposure to glyphosate alone and Roundup Biflo and Ranger Pro gave rise to statistically significant dose-related increased trends or increased incidences of benign and malignant tumors at multiple anatomic sites compared to concurrent controls, most importantly, but even to historical controls. And these are a range of different cancers that were seen that I've shown you earlier. There were increased incidences in both sexes, but there were some sex differences. For example, some cancer types, liver and breast, were seen only in males. Most tumors observed were rare for the Sprague-Dawley rat strain, which I think adds to the significance of these findings that glyphosate can induce formation of rare cancers. And it supports the IARC conclusion that there is sufficient evidence of carcinogenicity in experimental animals. And the results highlight the importance of undertaking such carcinogenicity studies in animals, starting at a prenatal stage of development that reflects real-world exposure situations. And that glyphosate alone gave rise to numerous different types of cancers, as we have seen, which includes leukemia, skin, thyroid, bone, and liver, at both the NOAEL, but even, very worryingly, at the regulatory acceptable daily intake. And however, in many instances, the results between the glyphosate and Roundup Biflo Ranger Pro commercial formulation exposure were very similar, indicating that glyphosate was actually the main driver of tumorigenicity in those particular tissues. But in some instances, as we've seen, that Roundup Biflo and Ranger Pro had high incidences of tumors in certain cases, such as skin, kidney, bladder, and the pancreas. What are the regulatory implications of these findings? As I mentioned at the beginning, the acceptable daily intake, the ADI, is based on establishing a NOAEL dose in animal toxicity studies. What the global glyphosate study has found is that statistically significant increases in cancer incidence at both the glyphosate ADI and the NOAEL doses, demonstrating that the current glyphosate NOAEL and ADI are incorrect, and that the glyphosate NOAEL at the moment must be lower than the current ADI and is unknown, basically. And in addition, what the global glyphosate study has shown is highlighted yet again that one must base NOAEL and ADI values on not just glyphosate alone, but on the commercial glyphosate-based herbicide formulations, because they had additional toxicity in this study. And so there are based on this, there are two major regulatory implications. The global glyphosates, by demonstrating that glyphosate and GBH formulations are carcinogenic hazards, under current European Union cancer hazard-based pesticide law, glyphosate herbicides should actually be banned, as simple as that. But for me, minimally, what needs to happen as a matter of urgency and as a precaution, the glyphosate acceptable daily intake, the regulatory permitted glyphosate acceptable daily intake must be drastically reduced. Because we don't know what the NOAL is, we don't know what that reduction should be. But in my view, as a precaution, it should be reduced by at least 100-fold, but possibly even 1,000-fold. And I'll just finish by acknowledging these are the institutions that supported the global glyphosate study. Thank you very much for listening.
Thank you, Michael. That was absolutely fascinating. Thank you so much. We've had loads of technical questions. I'm really sorry, we're not going to have time to answer them, but I would strongly encourage people to go and read the original paper where a huge amount of those questions will be answered. Michael, we've just got a couple of minutes, so I just wondered if you could share your thoughts very briefly on what your experiences is presenting these findings, not only in the global glyphosate study, but all the research you've done over the past couple of decades. What's your experience of presenting your findings to regulators? And why don't regulators tend to act on these studies? And we've even had people like the Dutch regulators coming out and already rejecting these results. So if you could just share your thoughts very briefly on that, that would be fantastic.
This is a very important and pertinent question, Josie, and it's a difficult one to answer. Why our past work has been ignored when it was again conducted in accordance with regulatory requirements? Because we're not given any reason why they're ignored by regulators. So I can't actually quote them in return. But so I really have to wave my hands and say that I can't answer the question basically, but I'm hoping that the depth and breadth of the carcinogenicity study that I presented here today will finally make regulators sit up and take note of just how deceptively toxic I would say glyphosate is, because it takes time. This is the thing about glyphosate, is that it can give you the idea that it's quite safe because, short term, it doesn't seem to give you much of an adverse reaction. But given enough time, as the carcinogenicity data that we've gone through now, it can give to very, very serious adverse outcomes, not just cancer, by the way, but other conditions such as non-alcoholic fatty liver disease, which is what my group has demonstrated in more than one study. So, and I'm glad to say that this carcinogenicity study data has been put to the European Commission by Pan-Europe, and they are now looking at it. And because in accordance with European Union law, they have to consider new evidence. And we hope that they will see it for what it is, which is that glyphosate and even more so its commercial formulations are carcinogenic. It's as simple as that. And that they need to consider highly restricting the use, or really in accordance with their own law, that it should be banned.
Thanks, Michael. That's brilliant. And just to say, from the perspective of civil society, it's really brilliant to see academia and civil society coming together in this way. So thank you so much. The controversy around glyphosate will continue to swirl. From Pan-UK's perspective, we see the amount of money that the industry puts into sowing doubt into your kind of research, taking from the tobacco industry playbook. So it's not necessarily too hard for us to see why these studies aren't taken as seriously as they should be, but hopefully that's beginning to change. A huge thank you to you and to everybody else who came along to this webinar. Sorry we didn't have more time. Just to say, Pan-UK, if you're in the UK, we will be launching the largest ever look at urban pesticide use by local councils in the next few weeks. It's a massive study. We've done 400 freedom of information requests, and this is very relevant because 99% of the pesticides being used are herbicides, and almost all of it is glyphosate-based. So it's the second most common route of exposure after diet to glyphosate in the UK. So if you would be interested in having that sent to you, please do sign up to our mailing list. And other than that, thank you so much to everyone for attending, and a huge thank you again to Professor Antoniou. Thank you very much. Have great days.